So good afternoon everyone. So this demonstration is regarding HPLC, high liquid performance chromatography. So as we have seen there, HRMS, high resolution mass spectroscopy. So what happens there? The principle is little bit similar. Okay. So this is high performance liquid chromatography. So here liquid chromatography means liquid separation is there. Okay. And main is purpose is, suppose we are having a sample, it contains different components. So we have to identify the components, we have to separate the components, and we have to quantify the components. Okay. So these three things will be happening in this experiment. Okay, in this equipment. So first of all, it is having some parts. Okay, this is the reservoir, mobile phase reservoir. Mobile phase, here is liquid solvent. Okay, and your sample is also prepared with the liquids having some solvent. So this is called liquid chromatography. So your first part is your solvent reservoir. Then this is the main component where you will be having an injector. Okay, injector, and your pump is here. Okay, this pump will send your sample with the mobile phase to the detector. Okay, so this contains your sample, your injector. Okay, and this is your column part. Okay, column. So this is your mobile phase. As you are talking about their mobile phase is containing the solvent, and this column is your stationary phase. Okay, so mobile phase will be coming to the stationary phase, and in the stationary phase mobile phase interaction will be there. On the basis of the interaction, separation will be there, and then after this separation with the mobile phase, your analytes which we have to actually detect, that will go to the detector part. Okay, so this is the detector, this is a detector, and this is a detector. So three detectors are there. One is here, it is your photodiode array detector, another is your refractive index detector, and another is your fluorescence detector. So those the components which you want to detect, if it will be having fluorescence activity, then you will go for UV fluorescence detector. If it will having some you are having some sugar molecule, so if you actually quantify this glucose or sucrose compounds, then we will go for refractive index index detector, and this is having also another purpose. So depending upon your analytes which you want to detect, so you have to use the detector. Okay, you can't use this three detector at a time. Okay, and this is the data system where you will be analyzing the data. So first of all, this HPLC doesn't contain your MS, mass spectrometry. We are quantifying, so this mass spectrometry is different thing. Okay, it can be attached to here, but here no mass spectrometry is there. So whenever you will use your sample, you will run your sample to detect your analyte, you have to use a standard. Understood? Suppose I have to analyze the phenolic compound, so particular phenol. Okay, so what I will do, I will run a pure phenol sample. Okay, phenols are many types. Okay, so suppose one standard I have to run. Suppose I am running, I want to detect, I have a juice sample. Okay, in the juice sample I want to detect what is the glucose percentage. Okay, so what will I do, I will run a pure glucose sample. Okay, so the glucose is the standard, and the glucose sample after I run, I have to run my sample, then there will be comparison. Okay, so the basic thing. Okay, so after the comparison with the particular standard, standard, you can calculate what is the percentage of your glucose or the concentration of glucose in your juice. Okay, is the example. So what happens, so we have different components are here. Okay, here as we saw there, you have to inject your sample. So he put the sample there, HRMS, and it was automatically going through. So you have to inject the sample through injector. Okay, these are the columns, I will show you. So this is the syringe. Okay, so this is very sophisticated, this small part. So you have to inject your sample over here. Okay, I will show you. Okay, how to inject. So this is the syringe. Okay, so you can actually inject your sample starting from 1 microliter to 100 microliter. Okay, so throughout this syringe you have to set, and you know the sample preparation yesterday, the sample preparation we saw there, these are similar principle. Okay, HRMS, HPLC, GC. So the sample preparation is, your sample should be dissolved properly, it should not contain any particles. Okay, if it is particles, then you have to, while you are injecting, you have to use the filters over here. Okay, so that your sample doesn't contain any insoluble material, everything should be soluble. After that, see, these are different type of columns are there. Okay, one column I am showing you over here. So this is one column, okay, it is having specific diameter. So this column contains your stationary phase, okay, and we are sending our sample through this mobile phase. So this column contains stationary phase and this mobile phase contains your sample. So the how this separation happens? The separation happens on the basis of interaction, okay. How it will interact? Suppose your sample is having different kind of sizes, okay. Some compound is having lower size and higher size. Size means according to its molecular weight. So if some compound is having smaller size, so it is having a stationary phase. So this mobile phase containing smaller analytes, basically those smaller molecules, they will stay here, and this with the pore, this stationary phase will be having some pore space, it will stay here because if it is small, and the larger molecule it will pass through the, you know, in the gas phase, and in the liquid phase, and it will go to the detector. So on that way the detection will be happening. Bigger molecule or higher size molecules will be detected faster as compared to the smaller molecules, okay. So this column varies according to your sample. The column where you can detect your glucose sample, sucrose sample, like carbohydrates, the same column can't be used for the protein sample. Suppose you are going to detect amino acid, okay, because the interaction principle is different. Somewhere it is size, somewhere it is polar. A mobile phase containing polar molecules, so it will interact with the solvent, polar solvent. So this is the thing, mechanism. So one is size, one is your your polarity basis. So another is three types of there, okay. So in this way your column is there, and this column will be fitted here, okay. Now I will show you the path, in which path it will, your mobile phase will containing your sample and go to the detector, okay. This kind of columns are there. So okay, this is having some particular naming over here. So this column is 5 micrometer is diameter, and it is mentioned over here. It is having some code name. It can't come with like you want to measure the protein, or you want to measure amino acid, or you want to measure carbohydrates. So it doesn't come like that. It is having some coding, okay. C18, C12 is like that. Okay. So now what happens here? I can show you. See, this is the thing, main thing I am showing here. These are the pumps, okay. 2 pumps are there. So this pump, 2 pumps are there. Here you can inject your sample, injector load. So when you are rotating to the load side, you will load the sample, then you have to close it, okay. It is having the like working principle is actually mentioned. You have to work like this. So these are the 2 pumps. So these are the line, whatever it is showing you, these are the line. Mobile phase will come here. So these are the small capillary, okay. Your sample mobile phase will pass through this. So what will happen? These 2 pumps are there. So suppose your sample, the analytes which you want to detect, it contains, it requires 2 solvents, okay. So you have to use 2 solvents. It's not like that you will prepare your sample in the solvent. You will prepare your sample in different solvent, and your solvent mobile phase will be different. So when will your mobile phase will be passing, and when will put your sample, inject your sample, the sample will be carried by the mobile phase, okay. So you want your mobile phase to be 60-40 ratio. So one is isocratic and one is gradient. Isocratic is, suppose 2 mobile phases are there. Suppose acetonitrile, another is another solvent. So you want this solvent should be 50%, this solvent should be 50%. That is called isocratic. So in that 50% will be there. So in the while we will be setting this data, you will be give 50-50. So 50% of the solvent will be going there. So when you want gradient, like suppose 70% of one solvent and 30% of one solvent, you have to mention it in gradient, okay. So simple, the user process using manual is very simple, okay. You have to give accordingly, and you have to set the flow rate also. You have to set flow rate, you have to set your pressure, you have to set your proportion of your solvents. So these are the parameters, okay. So the last part is detection, which we want to detect. So mobile phase containing the samples, it will be passing through the column, and in the column separation will be happening according to size or any interaction principle. Then it will be going to the detector will detect, and the data you will be getting in the data analyzer. Okay, so what happens when you are having a standard, separate standard, as I told you, have to run, and you have to run your sample. So there will be a peak. The peak will be observance versus your retention time. So what happens, that is the main, I have to analyze your sample. You are running your sample. Suppose I am running on amino acid, that is your tryptophan. Okay, so I have to run tryptophan standard. So first I run the tryptophan standard, it runs. So while running, retention time is there. This is the column. In the column, your mobile phase containing your sample is running, and your stationary phase is there. So stationary phase, mobile phase interaction will be there. Okay, on the basis of the interaction, some analytes will pass faster and some will slower. So those who are passing faster, their retention time in the column is less, and those who are passing later, their retention time is more. So the curve what is coming, the peak, there you saw the peak. So the peak will come your observance against your retention time. So you run your standard, as I told, tryptophan, amino acid you run, your standard you run. Okay, while you run your standard, it will be giving you a peak versus your retention time. Then you are running your sample. In your sample, the peak or the particular, like the same retention time corresponding to your standard will be giving you the same value. Understood? Analyte, the tryptophan standard I run, suppose at 1.3 minute retention time you are getting one peak, and that is your tryptophan. In the standard, when you are running your protein sample, in the protein sample you are getting same peak, same means not the height of the peak same, but the same retention time, the peak actually it is telling you the tryptophan. Okay, so you have to match the peak, and you have to integrate the peak, and after integrating the peak you have to get the concentration. Concentration. So what happens here, first identifying is there, tryptophan is there, then its quantification is there, how much amount present is there, and is your separation is there. Separation happened in the column. So this is the entire working principle and procedure of high performance liquid chromatography. Okay.
So, how to adjust RP of standard?
Sorry?
How to adjust RP of standard?
Can you repeat again?
How to adjust retention time of standard?
No, retention time we can't adjust.
We will prepare a buffer every time. So there may be some minor changes in buffer, minor parameter changes, pH and variable is there.
No, that comes under sample preparation, right? Suppose I am taking one standard, I am preparing the standard outside, and I am running the standard. So it's not like you are running one standard, then you are doing the experiment for a long time. You have to repeat the standard again and again.
So there should be no specific retention time for standard. Standard come out from column in between 20 to 25 minutes, 40 to 45 minutes. If my standard come out from column line, let's say about 30 minutes. So how to reduce the time if my standard should come in between 20 minutes?
No, it will not come 30 minutes. Like, no need to reduce that. At what time, retention time, because the interaction, you can't regulate the interaction process. We are giving input or sample from mobile phase. Interaction will be there, and the peak, whatever it will come at the corresponding time, like retention time, that you have to match with the sample. So you can't control the interaction process. Based on the interaction process, the retention time is coming out, right? So that's the main thing.
Well, if you prepare a buffer, let's say buffer have a pH, let's say 7 plus minus 0.2.
So that buffer is your mobile phase.
Mobile phase. Let's say one buffer have a 6.8 pH, which is acceptable on the basis that your RP will be next to 25 minutes. Next time when I prepare buffer, and let's say my pH is 7.2, it's also acceptable. Then again RP will change.
No, you have to be very specific. If little bit time different is there, it's okay, you can see it, but that is called human error. No, that's why you are thinking how to minimize the error. Okay, 7.2 everywhere standard deviation, you can go 0.02, not beyond that. Okay, that deviation, then obviously this is the precision measurement. Okay, because previously you want to quantify through UV spectrophotometer or any other way, but this has actually, the invention is here because of time reduction, multiple sample you can do, so many things, many advantages are there. So if you are not that much precise, then there will be like result difference will be there. So every time you run your sample like standard, why you are using the same standard then? Okay, you run your sample is standard. So if you are running, you are doing many times, then it will be adjustable by you. Okay, there will not be a great difference. Okay.
How much time does it take?
It depends on your like interaction. Suppose polar compound.
It takes less time than UV spectrophotometer.
No, not less time. You can do multiple sample. It will be a faster process, but there is some advantages. All the things can't be done in UV spectrophotometer.
Yes.
So that's what the thing. Like there is some advantages. Okay.
Here also different wavelengths can be measured.
Wavelength, no. That principle is different. No wavelength is here. And another thing, if you are having a mass spectrometer, then no need to run the standard.
Okay.
Because mass spectrometer it is having your database, okay, library database, so it will quantify the things, okay. So no need to run a standard. So that is the advantages over simple HPLC without mass spectrometer and yes, HPLC MS and with only HPLC, okay.
What's the benefit of using different solvents in mobile phase?
No, your sample should be actually that my sample is that solvent specific. I can't use, see, phenolic compound is there. So phenols are many types. One is hydrophobic, one is hydrophilic. OH is there, benzene ring is there. So you see, people are also extracting phenol by using methanol. People are using extracting phenol by using aqueous solvent, and people are using aqueous methanol solution. Understood? So it is different depending upon your sample. Okay. So if a sample is only like with one mobile phase, it is actually separating, then it's okay. But it needs to, like I gave you an example. So at that case, in that case, you have to use multiple, like not multiple, 2 mobile phase. Here it is given 3 ports. Okay.
So sometimes when we run the HPLC, the peak doesn't come sharp. We give some mobile set. So it is a sign of bet.
No, then you are telling in the standard running.
Standard and simple process.
Then you can repeat the thing. Okay. If it is coming sharp, then it is actually accurate. If it is coming like this, then while you are integrating the area and all these things, because then you are comparing the standard or it is MS. So if it is sharp, then you are getting some good result. Because it is mainly on area and all, so that's why it will be very. Any other question?
Let's say we are separating the isomers, then their permeation or gel permeation will be almost same. So how will we separate them? Like they will travel in the same retention time or almost same. So how will we differentiate them?
No, that part I have to actually check, because isomer I didn't work. Okay, isomer separation. So as there we are detecting, no, I think in that case isomer you are talking about, so that is molecular mass. Okay.
Molecular size as well. You told about size, based on size of separation.
Yes. No, based on size, different molecular mass. Isomers will be having different molecular mass. I am not actually, I don't know if isomers will have different molecular mass. I am telling. Okay. Suppose one is having higher molecular mass, lower molecular mass, small molecule. So it will be sticking to the pore, and the higher molecular mass will be passing faster. Okay, that is the interaction principle. So whatever we are talking about isomers. So if both are having same molecular, then there will be like a little bit. You have to give. You have to see how is it. But yesterday we saw HRMS. Okay, high resolution mass spectrometry. So there what happens? Isomers also it was showing. Okay. So I think.
No, actually I searched. We can separate isomers by this.
By this, okay.
Because isomers are having different structural arrangements, so it can be separated.
Okay.
But it's
So-
still tough.
So that we have to check. Okay. Compared to whatever examples I have given like according to the food material and food food related experiments. Okay. So this is gas chromatography. Now the demonstration will be. So I showed you that 3 kind of gases are there: nitrogen, hydrogen, and your normal air, not inert. So here is also inlet of the gases. Okay. So this is the gas, inlet pressure gauge, outlet pressure gauge. Okay. That was for the container. So after passing here, gas is actually passing through a pipe or like that, so some pressure drop is there. Okay. So that's why after coming here, this is the inlet and this is the outlet. Okay. 3 connectors are there. Okay. It is connected to the main system. So here this is the difference. All know like the difference between gas chromatography and liquid chromatography. Okay, so volatile compounds are mainly separated. As that kind of HPLC, you are working with, you know, your food, pharmaceutical company, food companies, okay, food chemistry, all these things. But suppose someone actually working some spice industries there, spices are normally volatile. So this kind of components, volatile components, we are going for GC, gas chromatography. Same thing, it is having, you know, mobile phase is gas phase. Okay, you are having your sample, here sample injector will be there. So, and this is your column. Okay, 30-meter column is there. This column is higher, there the column length is maximum 30 centimeter approx. Okay, here the 30-meter column is there. So this whatever you are seeing, fine wire is there, so that is your column, and after passing through the column it will be going to the detector. So all the things are arranged in one setup. Okay, there are different was there. So here the main detector is FID, okay, film ionization detector. Okay, so this is the setup, and after that is the database where you are going to analyze. So as I was talking about, so in GC the same thing, it is not GCMS, so simply GC. So to get your analytes, okay, the main actually the compound which you want, so you have to run a standard. So the same thing, you have to run a standard, you have to compare the standard. So in the MS, if it is having a MS, so since in GC you are only getting the curve of your observance versus your retention time. If it is having a mass spectrometer, then you will be getting observance versus also mass. Okay, from where you will quantify. So what will happen? So you see, we will inject the sample here. It will having pressure. Since it is now not in operational condition, so pressure actually it is 0. So you have to set different pressure. Okay, at what pressure you want to this outlet pressure. So this is the mobile phase. Here main the thing is your temperature is a main thing. Okay, there you are not giving any temperature, because since your analytes which you want to detect, it will be in a volatile condition. So you have to make the gas, make it to volatile stage. So for that you have to heat the sample. Okay, so what happens? 3 temperatures. One is your inlet temperature, one will be your column temperature, that is your stationary phase. Stationary phase is your column, and another is your detector temperature. Okay, because the same thing which will be separated, it will be going to the detector. Okay, detector, flame ionization detector. So you know flame what? So there will be 3 temperatures. Okay, so when you will be working, you will be setting all these 3 temperature according to your need. The inlet temperature, the stationary phase temperature, column temperature, and the outlet temperature. That is the detector temperature. So this is the main components, and main thing is this column is here 30 meter. Okay, can anyone tell why it is 30 meter? See, actually what happens, your sample needs to be in volatile condition, and your sample may contain also many sample. Since there it was liquid, so gas will pass faster than liquid. So for a proper separation of your analyte, its length is higher. And see, when I am talking about, you will getting peak versus retention time. Okay, so if it is in volatile condition, if you are getting many peaks, and peaks are very much sticking in nature to one another, so your resolution of the peak is not that much accurate. So then how you will separate? Okay, so for to obtain a better resolution of each peak, okay, to identify your analytes, so it is having higher length 30 meter. Okay, that is okay, you know, make in a coiled fashion. So what happens, you have to set your temperature over here, so when you are injecting your sample will be converted to volatile material. Okay, so gas will be there, gas will be passing through the, you know, higher length columns, and it will be going to the film ionization detector, it will separate there. Okay, so and other things is temperature, different temperature. I think certain things having limitation, temperature limitation, it can go maximum 330 depending upon the different manufacturer. Okay, 330 something like that is temperature condition, is some minus range will be there. I am not accurate about this temperature range. Inlet is, you have to set also temperature. This flame ionization detector is having also separate temperature. So the principle will be little bit same, but principle is not exactly same, little bit difference is there. but it is working. That is for liquid chromatography, that is gas chromatography. Okay. So if any doubt, anyone can ask. If anyone has worked with this equipment before, any doubt, anyone can ask.
Only volatile sample can be done.
Volatile means you have to, your sample should be in volatile nature. That's why you are using here temperature. And there are 3 detectors were there. Here only 1 detector.
The column length, is it a constant one or it changes according to the sample?
No, it is 30 meters here.
Constant.
He has given the column that has been given 30 meters. Okay. So 30 meter, it's not like depending upon the sample. It's like whatever the sample, it will be separated in that length only. There may be different length.
Because there we change the column height, everything.
Column height, the column size.
Yeah.
Size.
But here it's not like that.
Here they have actually they supplied 1 column length only. There might be, I don't know, different lengths of column. It may be there, but it should be like more length. Okay, it's not like that much. And you see there the column packing, like it is thick. Okay, inside it will be very less, some micrometer diameter will be there, but the design of this column and that column is different. And this is the oven. Okay, you see behind a fan is there. So this oven, this thing should be heated. Your column should be in heated condition. Okay, column, because this temperature is set only to heat the column. Okay, so the column will be heated condition, so your sample will be in volatile matter. Yes.
If blank sample showing some impurities in column, how can we remove the impurities from?
You have to wash the column.
How can we wash the solution?
No, there is a washing procedure. Okay, so you have to wash the column. See, this washing is the main part. After I use it for my sample, I have to wash it. Main drawback is there. The troubleshoot will be this. You know, this column, it will be having higher price. Okay, so column affordability is so a, you know, great. You know what can thing. So that's why you have to clean properly. Okay, its procedure is there, different solvent. So whenever you are running your sample, also before running your sample, you have to make a baseline correction. Okay, so that baseline correction, after doing all these things, you have to run your sample. So avoid impurity. You know, you don't know when you are getting the result, you don't know whether it is the human error, whether you are error in your sample preparation, or whether error in your washing or any impurity is there. So to avoid all these kind of things, so you have to clean properly. Okay.
Sir, can it detect azeotropes?
As you told, there no.
No, there it was isomer. Azeo.
No, I am not sure about that.
Basically, a mixture of 2
Volatile compound.
Same body forms.
Okay.
And cannot be separated by normal temperature.
Hmm.
Can it distinguish that?
No, we didn't do particularly. So it may be there. We have to check it. Okay, but I am not, confirm about that. So particularly in food sample, you know, suppose you are having some volatile compound. I told you spices, any other volatile compounds, you are going for that. Okay, obviously it will be having wider applications. All these packings are there. Okay, because it will be getting heated. No, so that's why. These days, this MS are coming. So because of that, your detection will be more easier and quantification.